All right, let's do AP Macroeconomics Unit 2.6. I'm gonna do this before 2.5 and 2.4, I think, because I think it makes sense more doing this first. So let's explain that. I'm gonna sort them in order of College Board, but I would recommend start with 2.6. Um, so what is nominal GDP? Nominal GDP. Nominal GDP. So that is not corrected for inflation. So this is just the total number of goods and services, and you're not kind of accounting for inflation. So just no correcting for inflation. No CORRECT. No correction for inflation. Lay. That's a horrible O. PION. No correction for inflation. And so here's the nominal GDP. There's no correction for inflation here, while the real GDP is. So real GDP. It is corrected for inflation. And so let's kind of do an example with this to show this. Now let's go work out an example with this. So over here we have an apocalypse. It's the end of the world. We have only two goods left in our economy. We have cheese dip and milk duds. It is the year 2035 now, and we want to see how inflation has changed. Uh, and we want to basically measure this inflation. Okay? And the price of a thing of cheese dip is $10 for a pint. A pint of cheese dip and a singular milk dud costs $2. I know, it's absolutely insane. Inflation's been really bad in like 2031, but we don't see that information, okay? Just trust me. So first we need to calculate the nominal GDP. So nominal GDP. And whenever you hear the word real GDP, you need to, or real space anything in economics, it's usually correcting for something. So real income or real GDP or real CPI, things like that. It's correcting for something, but this is the just mathematical GDP for that year. So we don't have any information about the rest of the economy. And so GDP, if we remember back in one of the other videos, GDP is I, C plus I plus G plus NX. So if GDP is C plus I plus G plus NX, then we don't have any information about investment or government and exports. We don't have anything about this information. So we don't have to worry about it right now. We just have to look at this consumption. So we here in 2033, so we're going to calculate the nominal GDP for each of these years. So 2033, our nominal GDP would be the, we need to find the total price or total revenue that this apocalyptic society has gained, okay? So that would be the revenue. And total revenue is equal to price times quantity. So we now have 10 $10 times 400 for the cheese dip. And then we have 2 times the 1,000, 2 times the 1,000, and this is in dollars, for the milk duds. And that is $6,000. $6,000. This is the nominal GDP for 2011. All right, what about for 2012 or 2034? 2034. 2034. Well, 11, we have price of 11. So 11 times 500, because that's the number. You can see that the GDP is going to rise because the quantity is going up. And so the goal of the real GDP is to only look at this changing quantity and not the price changing. We just want to look at, hey, is the economy growing? We want to isolate the growing economy and the fact of just selling more stuff and just how much price is rising. So I will finish out these and calculate the nominal GDP. So here are my nominal GDPs for those years. And you can see just how much the effective GDP is increased. It's going up by a lot. But instead, we want to account for the prices increasing. So let's calculate our real GDP. Real. This is our real GDP. So for 2033, that will be our base year. A base year is just an arbitrary year which we're just comparing our inflation rate to. So if you're doing a problem, it'll probably say, hey, choose some year to be the base year, and you'll do everything relative to that year. Or if it doesn't, you will explain, hey, this is what I'm choosing to be the base year. But it should likely be that the first year is the base year. And that is what I've seen a lot of people do, and this will just make your calculations a bit easier. So with 2033 as our base year, what that means is we're going to use the prices from the base year. So we're only looking at the change in quantities. So I'm going to circle these so I remember to use these prices. So for 2033, the prices aren't different. So it is still 6,000. 6,000. And for 2034, 34, the price will be 10 and the quantity is 500. So for the cheese dip, so we're going to say 10 times 500, and then we're going to say 2 times 1,100. 1,100, which will be 7,200. 7,200 dollars. So you can see that from 6,000 to 7,200 is a lot less of a jump than 6,000 to 8,200. And that's because we're only looking at the growth of the economy from this change in quantity, not both the change in price and the change in quantity. So now I'm going to talk about the GDP deflator. So this is basically the ratio to see how the prices have changed. So if the GDP deflator, I'll just write deflator, DEFLATOR. GDP. The deflator is the nominal over the real GDP, and then times 100 because, I don't know, people don't like decimals or something. So, if we look at the nominal and real GDPs for our base year, that'll be 6,000 divided by 6,000, which is 100. And so unless you've royally screwed up your problem, if you're ever told to calculate the GDP deflator for the base year, then it should be 100. So if we wanted to say the deflator for 2033, which is our base year, then that will be 100. What about for 2034? 2034. Well, that will be 8,250 divided by 7,200, which is about 115. And for 2035, it is 10,800 divided by 8,400, which is about 129. So now I'm going to quickly go over the inflation rate, and then we can maybe do a practice problem on this. So the inflation rate, we're going to calculate the inflation rate for our real GDP here. So we can't really calculate for 2033 because we don't have the information here. But let's instead do, uh, we'll start with 2034. So our inflation rate for 2034, inflation for 2034 is going to be the price at 2034. So the price, which is 7,200, or the GDP. So the GDP of the current year minus the GDP of the old year, 6,000, and then divided by the GDP of the old year, 6,000. 6,000, and then times 100%, of course. And this is equal to 20%. 20% inflation for 2034. But generally, you do not do this with the real GDP. So we're going to do this with the GDP deflator instead. And so if we do basically the same thing where we say, let's do the current, which it would be 115, minus the old, which is 100, over 100, times 100 is just 15%. And then if we do the same thing for here, 129 minus 115 over 115 times 100, that is about 12%. 12%. So you can see these inflation rates are not very good. We want 1 to 2% inflation, not 15 to 12%. So everything we have learned at this point can be solved in this problem. We can do this. So we have, this is a real question from like think 2008 or something. So it says Galaland produces three final goods, bread, water, and fruit. All right, so these are final goods. Okay, so no one's gonna turn the water into, uh, I don't know, some fancy water machine and sell it, or no one's gonna turn the fruit into a fruit hat and sell it. I don't know how they're gonna do that, but they just are. So these are our three final goods. And so let's calculate the GDP. So the is GDP is equal to C plus I plus G plus NX. We know that, but we don't have any other information other than our consumption items. So we just only have to calculate the total number of profit made from our consumption items. So we have 400 loaves of bread, 400 times $6 per loaf, 6, and then we're going to add that to our 1,000 gallons of water at $2 a piece. So times, put these in brackets or parentheses so you know, hey, multiply them, just so no one gets confused. And then we're going to do the same 800 pieces of fruit at $2 per price. So that's 800 times $2. And so if we multiply and then add everything together, we get a GDP of $6,000. 6,000. And do not forget the dollar sign. All right, so this is part A. What about part B? Part B says assume that Galaland has a GDP deflator and GDP price index in the base year. And 150 is this year. Okay, so obviously they're going to have 100 in the base year, but it just technically it might be off ever so slightly depending on the month. But generally it's going to be very close to, if not 100 in the base year. So we have, and 150 is this year. So we don't necessarily know. Let's see. Okay, so this is the GDP deflator. So we want to calculate the inflation rate. So our inflation rate, IR, that is not whatever it is, just write out inflation rate, but I'm lazy. Okay, the inflation rate is going to be this year's, so this year's GDP. So GDP, the deflator this year, so this year, all right, current, CUR, minus the GDP old, GDP old, over GDP old. And the GDP in this case we would be using our GDP deflators because we don't have any other information for our the GDP for at that point. So let's use our GDP deflators and calculate. So if 100 is the base year, so 100 is this number, then we're going to go over that one number, and then you have 150. And so the percent is inflation is 50%. So not 50%. That's kind of high inflation. But here is part B, BI. What about II. So what is our real GDP? So let's think about our GDP deflator. That is our nominal GDP over our real GDP is our deflator, GDP deflator. So we have our nominal GDP, which is 6,000, and we have our GDP deflator. So we can now start substituting in things, and then we can do some algebra. So if our nominal GDP is 6,000, 6,000, and let's just move our real GDP to the other side. So and this is our, I don't even know what says. This is supposed to say deflator. D, E, that is not an E, D, E, F, deflator. So our real times our deflator. Well, our deflator is 150% or 1.5. That is very important. Our deflator is a percentage. It is not a number. So when you are doing math with it, be sure to convert it to its decimal value, because otherwise you're going to be in for a world of hurt when you lose a point. So we have 6,000 is equal to 1.5 times our real GDP, and then we can divide both sides by 1.5 to get our real GDP. So 6,000, 6,000 over 1.5 is 4,000. 4,000. $4,000. All right. What about C? Since the base year workers have received a 20% increase to their nominal wages, that's pretty cool. If the workers face the same inflation that you calculated in Part BII, what is the real wages? I haven't explicitly covered this, but we can kind of work this out. We can kind of think this. So if you have received 20% increase to wages, so C, wages are increased by 20%. We make 20% more, but we have this inflation rate of 50%. Technically, we have a plus 20% because of the wages, but minus 50% is what our effective wage is because of the inflation. Then we have actually a net negative 30% over whatever time period this is. So this is actually a loss of 30% because the inflation subtracts 50% of our wage, essentially. Our effective wage is actually decreased by 30%. All right. If the GDP deflator in Galaland increases unexpectedly, would a borrower with a fixed interest rate loan be better off or worse off? So the GDP deflator. So let's try and pick apart this question. If the GDP deflator increases, so for whatever reason, we have a GDP deflator increases. What does that mean? If the GDP deflator increases, there is more inflation. Because there is more inflation, people can essentially buy less crap. I was able to buy 5 computers and now I can buy 3. Inflation. So you can essentially buy back less. But the fixed interest rate also is now essentially less. So because there is higher inflation, so they would actually not worse, they would be better off. Because with that money, they would have been able to, they can now pay it off using less essential, effective real dollars. They can now pay it off with less money, essentially, because of this inflation. I know that this is a trick question, so if you want to kind of think about this for yourself, because the inflation rises, they don't have to effectively pay as much.